Okay, so now substitution in definite integrals. So if I want to state it precisely, the theorem is this. So if you have integral from a to b, but you have f of g of x multiplied by g prime of x dx, this you can, in principle, if you have this structure, you can write it from a to b, and then you can have you can have u substitution. I just talked practically. So you take u to be gx, and then you differentiate. So du becomes g prime of x dx, as before. So this becomes du, and this becomes f of u. And then, as I told you before, x goes from a to b, then what happens for u? U is g of x. If x is a, so it becomes g of a. And if x is b, u becomes g of b. At least you don't need to memorize. As I told you, this is a structure of the theorem. But of course, you know that if you want to guarantee integrability and using these theorems, this integrand should be continuous. So this means that this function should be differentiable, otherwise it doesn't make sense to talk about g prime. And the second thing is that f is acting on g after x, f acts after g, so it means that g of x, the values of g of x are within the range of g of x. And f on that range should be continuous. Okay? So these are usually always satisfied, so you can use them, but there are some subtleties that I will describe. Okay, you can see the proof of this in the book. It's not very strange and hard, but this is the idea. If g is differentiable and f is continuous in the range of g, so this part will be continuous, g is differentiable and is continuous by the theorem we had, so the product will be continuous and this will exist. In that case, this is the way you do it. And that is exactly, in practice, you have to be careful about what I wrote here. That is what you really need. For example, this is the example in the book. You are supposed to calculate this integral from 0 to 8, cosine square root of x plus 1 divided by square root of x plus 1 dx. Okay? So in principle, when you see this question in the exam, you usually remember about the fundamental theorem of calculus to calculate it. Okay? And then it means that you need a primitive function for this. So you need to learn you need to use the techniques you have learned to find a primitive function. Usually, sometimes you need to do change of variable, but you remember you have to switch back to the original variable in order to use these limits. But the whole point of this theorem is that when you change the variable, you also change this limit accordingly so that you don't have to switch back to the original variable. Because, by the way, we haven't gone through these exercises. Sometimes you have to do 2 or 3 substitutions, one after the other, so that you can find the primitive function. And then, if you don't change the limits accordingly, you have to switch back 3 times and then put the old numbers. So this is beneficial to use it. I always use it myself. So now, if you want to solve this one, you have to have enough experience. If you want to solve this integral, what do you think is good choice?
Root x plus 1.
U substitution, yes? Mm-hmm. Why is that a good choice? Because if you take u to be square root of x plus 1, the derivative of u with some scaling factor will appear here in the integrand as well. When I take du, the derivative of this one is 1 over 2 square root of x plus 1, but dx. This combination that you see here is very similar to what I got, except with a factor of 2, but I can get rid of that factor by multiplying by 2. So I multiply everything by 2, this becomes 2 du is equal to 1 over square root of x plus 1 dx. Okay? Now that this integral is a definite integral, one more step is good to do. So I would say that the old limit is from 0 to 8. This means x goes from 0 to 8. What does this imply for my new variable u? X is what? 0. I put 0 instead of x, a square root of 1, so the limit of u is 1. And if x is 8, 9, square root of 9 is 3. And by the way, be very careful. I hope that I have some of those examples in my notes. Sometimes when you put the limits that you get are in different order, meaning that the bottom one will be larger than, don't change it. You have to keep the same order. Okay? So don't think that, okay, now this becomes 3, this becomes 1, I have to switch it. No, because if you switch it, you have to pick up a minus sign. If you do that, that's okay, but don't switch it on your own. Okay, but I will go back here. I is equal to integral. Everything should be rewritten in terms of u, even the new limits. Instead of going from 0 to 8, I go from 1 to 3. And then I have cosine u. And then this part is exactly 2 du. So this becomes times 2 du, but 2 is a constant. I can pull it out. So this becomes integral of cosine u du. It goes from 1 to 3. But this is a very simple function now. The derivative of cosine of u when u itself is variable, a primitive function for that is sine u. But I also have a factor of 2. But then I have to run it from 1 to 3. So it means that I replace u with 3, so it becomes 2 sine 3, minus I replace u with 1, so it becomes 2 sine 1. That's it. That's the answer. If I didn't switch this one, I have to switch back to x and then use the old limits. That's possible. Any questions? Okay. So now let us see. Oh, the notes are there. So let us see what is coming next. So one thing which was not properly probably addressed in the book, there are some cases that you have this but you don't have g prime there. Okay, so you have, in the book they haven't discussed about this properly that much. So what happens if I have f of g of x but without g prime of x there? Okay, I want you to feel it yourself. Let us say, for some reason, I still want to take g of x u. What will be an obstacle in front of me? Can you see that? Because what I want to do, still, you see there is no g prime left anymore. I'm just thinking about this. You might say that, okay, let us take u to be g of x. Okay, let us pretend nothing strange happens. For the limits, I don't have any problems. Because you might say that, okay, x goes from a to b. What do you think will u go? U goes from where to where? Replace x with a, replace x with b. So that's not a big problem. Yes? But when you introduce a new variable, what was the strategy to get rid of old variable everywhere? Yes? When I take the u here, it becomes g prime of x dx. But this g prime x is not there. And I am not allowed to keep x. So you see that you are a little bit in trouble. Yes? Why you want to do that? So you want to go here and replace a with g of a. So far so good. gb. And then you have f of u. That's also very good. But dx, I am not allowed to keep x there. I have to get rid of dx, but that's not possible. Because if I want to do it, in the previous case, this combination itself was du. But in this case, you want to get rid of dx. What do? You write dx is equal to du in the best scenario. You write this, and still you put it back there, you are still in trouble, yes? Do you agree? Because there is an x there again. Okay? So, it's not working. Do you agree? But, do you see what is escaping from here? Because that is your strategy. Your strategy is still to get rid of old variable. In this normal way, it is not possible. Because I still have g prime of x. So I have a mixture, yes?
If we say, instead of saying u equals g of x, we can say x is equal to g inverse of u.
G inverse, and that is the subtle thing. Because the function should be invertible. So that's what I'm saying. So this means that this strategy apparently is not working. But let us do something else. Let us start from here again. and then I get u equals to g of x, and then I would say x goes from a to b. These are okay things. So nothing wrong was here. The only problematic part was that if I do it direct way, I will have this g prime x hanging around me. Yes? So I have to get rid of it. There is only one way to get rid of it. Instead of differentiating here, I would say that x is g inverse of u. Do you remember inverse function? But there is a big question mark. Because not all functions are invertible. Do you agree? So, if your function g is invertible on this interval, for example, it is strictly monotone, and strictly increasing, strictly decreasing, or something like that, then this is allowed. In that case, that is doable. Why? Because then what you do, you write dx. Dx becomes the derivative of this one with respect to u. Let me write it with respect to u. And then you write du here, yes? And then what happens now, if you put everything back in your integral becomes integral from g of a, g of b, and then I have f of u. Instead of d of x, I put this one, d du, g minus, don't worry about the complicated form of it, but what is my point? My point is that everything is in terms of u. Okay? So this is also a technique, I don't know, for some reason, and I try to give an example that you can do it at this level. So let us do one example, then you will understand what I exactly mean. So these are sloppy things. If you don't mind, let me put everything in quotation mark. Because, yeah, more or less it is precise, but we have to make it very rigorous. So this example number 12, I want you to solve this together, or to solve it together. 0 to ln of 2. It's a very simple integral, by the way. We want to calculate this. Okay, so how should I calculate this? Is the battery not? Okay. So, it is one of those integrals that it is not that easy to guess it can be solved using substitution. Yes? If I had another e to power x, this problem is simpler. Even though apparently I am making it more complicated. If I have given you this before, so can you tell me what should I do? This one you can take u, and then your g prime is there. You know, when I differentiate, the derivative of this one times dx is du, and then you can take this one and put du, and then the denominator u, and everything is written in terms of u. But the problem is that I have taken this off and I put 1 there. Okay? So I hope that you agree this is not going to work. Okay? So let us do inverse substitution now. So I start with this one, u is e to power x plus 1. And then what I do, I calculate x first as an inverse function. But is this question mark acceptable here? Is it possible that I find the inverse? Is this function, what do you say, monotone? Yes, this function is always increasing. So it is invertible. It is invertible, so I can find its inverse. How should I find inverse? I need to find x. So I would write 1 minus u is equal to e to power x. And then I would say x is ln of u minus 1. Yes? Because it is.
Why don't we just multiply and divide by e to the x? And then we have a partial fractions and we have a normal substitution that works.
Yeah, that works.
Yeah, okay.
I realized that when I did that. Okay, but let me not do that because my goal is to tell you how to do this one. Because sometimes it is inevitable. You have to do this way. Okay, but you are right. When I did that, I realized, okay, I can find e to power x as in terms of u and plug it back there. Yes, that works. Yes, that's completely correct. Okay, but what I'm saying is that taking this step from here to here, I have to make sure that my function is invertible. Okay, that was exactly the mistake that the examiner of that question made, because that function was not invertible everywhere. Yes, you remember this was the substitution we talked about yesterday because of -1. That was a coincidence that the answer was correct. Because that function is not invertible on the whole integral. So we have to split it into two parts, positive and negative, and then combine them back. Okay? So, but this is invertible, I don't have any, so this question mark is satisfied here, and I get this one. And I can calculate dx. What is dx? Dx is 1 over u minus 1 du. The derivative of ln of x. ln of u minus 1 is this one. And then I put everything back, but before doing that, let me take care of the limits as well. So x goes from 0 to ln of 2. Then what happens to my u? What happens to my u? If x is 0, this becomes 2. If x is ln of 2, what happens for u? If x is ln of 2, what is u? E to power ln of 2. 2 plus 1, 3. So this means that my integral now becomes what? My integral becomes integral. Instead of going from 0 to ln of 2, I go from 2 to 3. And then instead of 1 over e to power x plus 1, I write 1 over u. And then instead of dx, I put the expression in terms of u. And everything now is in terms of u. Yes? This is possible here because my function is invertible. Otherwise, you should do it in your way. But anyway, you will get the same integral.
Yeah.
Yes? But do you remember how can I solve that?
Partial fractions.
Yes, this was yesterday's lesson. Yes? Because this becomes integral from 2 to 3, 1 over u times u minus 1 du. U times u minus 1 is a polynomial in u. This is also a polynomial, but constant polynomial. And the degree of the numerator is smaller than the degree of the denominator. It's exactly the lesson yesterday, but the simplest one. So do you remember what should I do? I need to do partial fractions. So I would write this. I decompose it to two fractions with the denominators u and u minus 1. These are degree 1, so I put constants up there and calculate a and b. Okay? So do you remember I multiply everything by u times u minus 1. This becomes 1, a times u minus 1 plus b times u. I don't know, you can do that trick I told you, or you can just do it properly. I multiply and factor u out. This is what I get. Do you agree? Or this is so simple that you can even guess the numbers. But anyway, a should be minus 1. A plus b should be 0. So this means b should be 1. Yes? I put them back here. So the integral I becomes integral from 2 to 3. A is minus 1. B is 1. Yes. And then of course I split it, minus integral from 2 to 3, 1 over u du, plus integral from 2 to 3, du over u minus 1. But both of them we already know. The first one is minus, this is ln of absolute value of u from 2 to 3, plus ln of absolute value of u minus 1 from 2 to 3. Yes, and then I put the numbers. I put 3, so it's minus ln of 3, absolute value of 3 is 3, plus ln of 2, and then I put the numbers here, ln of 2, minus, I put 2 ln of 1, but ln of 1 is 0, so it becomes 2 ln of 2 minus ln of 3, or if you want, you can write it as ln of 4 over 3. That's the answer. So remember this. The example that I have mentioned in the notes, I have written that, for example, you want to do this integral. This is not an easy, I don't know, it is doable, but I don't want, my point is not to do it. My point is to understand that if you don't care about that invertibility, you will be in trouble. So let us say that I want to calculate this integral. By the way, when you see minus 1 to 1, think about evenness and oddness. Okay? So if you do that one, then you survive, because then you go from 2 times 0 to 1, and there is no problem, you can calculate it, because might be I was a little bit careless. I can change it to 2. Which one I have chosen in the notes? Yeah, I was a little bit stupid there, because from -1 to 2, from -1 to 1, if you know that you can write it 2 times from 0 to 1, your problem is solved. But let us keep it like this. Okay? I will change it for you in the notes. If I want to calculate this, I want to ask your opinion. So you take it to be this. And let us continue. You want u to power 100, that is no problem, but you want to get rid of x here. If I just differentiate, I will have 2x dx, but I don't have an extra x to help me to get rid of it. So it means that it motivates me to find the inverse. And that is what I want to say. So if you take this one to the other side and just take x square root, first of all, you know that you should be suspicious about taking the square. Why? Because I have to put plus or minus. And plus or minus is an indication that this function is not invertible. Because you see that this is x squared plus 1, and the graph of the function is here. So if it is -1 somewhere here, and then 2 somewhere probably there, and you see that this function is not 1-to-1. So it's not monotone. It's not monotone, it's not invertible. But I am pretending as if it is invertible. Then you see what happens now. If I do that, what happens? Okay, I will take dx. So this is not possible, not invertible. But I just want to say that if you don't care about that, invertible. Okay, but let us see what happens. Then you get dx is equal to 1/2 square root of u minus 1 du, yes? And let us go back and put the numbers there. Oh, okay, now I understand what I put 1. So let us put it 1, okay? Then I becomes equal to integral. Can you tell me what are the new limits? What I am supposed to do? Instead of x squared plus 1, I put u, so u to power 100. Instead of dx, I put that expression, no problems. That's actually good because it is in terms of u. But now let us see what happens here. If I put -1 here, u becomes 2. If I put 1 here, u also becomes 2. And then what do you get for the integral? You don't even need to calculate this, because whatever it is from 2 to 2. And then you get 0. Yes? Because we are living in this damn planet, we know that the life cannot be so simple, You can feel there is something wrong going on, yes? Because otherwise, I am not doing anything. I'm just writing from 2 to 2 and it is 0. And I don't care how complicated it is. But how do you know, by the way, 0 should be wrong? Because might be you say that, okay, no, 0 is correct. How should I know that 0 is wrong?
And the function is always greater than 0.
Yeah, I mean, from -1 to 1, there is an area here. And that area is definitely not 0. Yes? So this is the reason. If you don't care about these subtleties, you might get erroneous answers. So you have to be very careful about the conditions in the theorems that you use. And then I have written a question. If you insist to solve this problem, you will not be able to solve it because that's not an easy integral. But if you want to use this one correctly, what is the first thing you do?
You split it into
You have to split it from -1 to 0, because then the function becomes decreasing and it is invertible. Plus, from 0 to 1, the function becomes increasing and it is still invertible. But what will change here? Then here, for one part, you will get the negative one. For one part, you get the positive one. And then if you take care of all of them, you will not still be able to solve this integral. But what you can do is that you can do it in a proper way. Okay? That is important. I want you to understand, if you don't do it the proper way, you think you could solve the problem and the answer is 0. In principle, the answer is not 0. Okay? My goal was not to tell you how to solve the integral. I wanted to see what things you